Hi again. We'll continue our discussion on life tables, but now we will look at what is called the illustrative life tables. That usually you have it at the end of the textbook in the annex, but also what we will use the Society of Actuaries (SOA), Society of Actuaries life tables, and those life tables I'll show them to you right away as we speak. If you go to soa.org and look for live tables, you should be able to download it. I will put it also in our learning, in my learning space, so you can access them. But let me insert them here so we can do few questions based on this on this one. So I'll include them. Already saved them as PDF. I went to site of actuaries, soa.org. There are many tables, but I'll just select the ones that we need for today. So this is, if you go to the Society of Actuaries website, you will find these live tables. And this is the standard for this, what we need to select at interest of 5%, right? So you will have, do you remember our L of X? We already discussed L of X. Those, don't forget about this for now. We'll come back to it later. Just let's focus on these guys. Also forget about. For the time being, let's look at this. We'll come back to the rest later on. So you have age 60, and then it picks up after age 60 to the age 100, right? Let's forget about those. So let's take a few examples to understand what we mean. We understand that what is X? X is the age, right? I don't think any one of you guys don't know what we mean by X. L of X, the previous session, we looked at what is L of X. It's the cohort that we follow. So at age 20, this life table has a cohort of 100,000, right? So if you look at L20 is 100,000. Then you trace them, right? You trace them. And if you want, let's say, if you take, let's say 100, this is age 20, have 100,000. Age 21, you would have 99975, right? 99975. So the difference between them, which is 25, is D20 is 25, right? So D20 is equal 100,000 minus 99975, right? What if you want to calculate a Q20? Q20, simple, and there is no one here, it means that there is one, right? But we usually don't write it. So it will be L20, because this is the age we evaluate, and we look at L21, sorry, L20 minus L21, right, which is D20. So we take L20 minus L21, already we calculated 25, divided by L20, which is 100,000. What that gives us is 0, 0, 0, 0, 3 zeros, right? 25, right? 25. And this is, again, a Q20. But this life table, it's interesting because it's also, it gives us Q20, right? You see Q20? It's here. Right, so we have Q20, you have, so you don't need to calculate it for one single year. But what if you want P20? It's 1 minus Q.
I can learn to understand you much better if I can get familiar.
Oh, I don't know what happened here. Yeah, by accident I hit something on the computer. So anyway, we'll continue, right? It's 1 minus 20. So it will be 1 minus 00025, which will be 99975, right? This is one way. This is one way to calculate it. The other way, or you can remember P20, this is 2021. We need to survive this one, so it will give you and evaluate it here. So it will be L21 divided by L20. The cohort survived to age 21 divided by the cohort of 20. And the cohort of 20, we remember, it's 100,000. The cohort of 21, you look at it, 99975. Which should give you the same, very same answer, right? So this and this should be equal, right? Simple. There is nothing difficult here, right? Nothing difficult here. But we make it easy. We started with age 20 just to illustrate it. But what if we wanted to find the cohort at age 60? Let me use different. The cohort at age 60. The cohort at age 60, this is simple. We go to the table, we look for age 60, right? We look at age 60 here, right? You see it? So the cohort for age 60, if you can see it, maybe I should make it a little bit bigger so you can see it, right? Do you see it? 96634. 9 6 I can't remember 96. It's hard to remember those numbers. 966341. 966. But I encourage you also to, well, I assume, as I mentioned last time, I assume that you need to have this printed, and you look at it. So I assume that all of you now, instead of looking at the screen to find the value, you do what I'm about to do now. I will use the table here, right? So it helps us to work it out. So it's already posted in my learning space, right? So you can use it. And the source of it is the Society of Actuaries. It's located at soa.org. So you look for life table, it should come out, right? So we look at L60. It's easier instead of keep going. L60 is 966,634.1, right? But again, like it should be here, right? This one. What if you wanted now, let's take a harder one. Let's say we wanted 10P60. 10P60, the best way to calculate it is just visualize it. I always, in actuarial mathematics, I always like to visualize it. Interest theory and actuarial mathematics, you will be doing great if you just visualize. It helps you to, before you start doing the mechanical calculation, it helps you to understand what you are doing. So remember that we are at age 60 and we wanted to see what happens at age 70. And what we are interested in is to see the survival rate, for a person who selected at random from age 60, what is the probability that he or she will survive? So simply we take the cohort who survived, L70, you divide it by L60. We already looked at L60 just here, right? It's 966,634.1. Let's look at L70. I'll go back just to help you to see where I'm getting it. This is the table. You don't have 60 in the first page here, right? You flip the page, which I already downloaded for you. You will see L70. It's 91082. 91082. 91. Which, just to double check, I will look at it one more time here. Again, this is the life table you need to look at. Do you see it? It's pencil underlined in pencil. Right. Once you do that, you use your calculator. Simple. It's 91082.4 divided by 966,634.1, and what I got here is 9, sorry, I think I made a mistake here. Yeah, it's correct. Yeah, 94226. Let me just doubly check it because it seems strangely always good to do it. This is L70 divided by L60. Take your time. Mm. 94255. That's what I got. Sorry. Yeah, little difference, right? It can be a little bit confusing. Yeah, I made just mistake, right? Okay, very good. Okay, now let's look at 60, just to double check because it's 66341. Okay, let's take another example. You know, like those numbers, you need to copy them accurately, you know, because it's very difficult for me to keep going to the same screen and remember the number. But it's, you use your table here, and like what I do, underline it with pencil. Like let's take another example here, maybe 5Q60. Visualize it. You are at A60 where I got the 60, this one, and you want 65. We're not looking at survival here, we look at survival. Here what we are looking at, death, right? This one is straightforward. You can say L60. Why L60? Because this is the cohort we start with. We are calculating probability on that cohort, right? So L60, so all we need to do is the death between 60 and 65. How we get the death between 60 and 65? We start with the cohort L60 and we see who survived to 65. We subtract those who survived to 65. So if you take the cohort you start with, you look at who survived to 65, so the difference between them, the death, and you divide it by what you started. So we need L60 minus L65 divided by 160. Let's take one by one. Again, you need to go back to your table. Let me highlight it here. So I'm you now, if you're listening to this, you should have your live table with you and you compute it yourself. So we start with 60 minus 65. 60 we already defined it. Now we need to look at 65. We don't have it here, so flip the page to 65. 94579. So what I found is in my table here, we know the 60, we already got it, 6634.1. We need to subtract the 65, which I already looked it up for you. 65 is 9.7. If you didn't see, for instance, if you didn't see where I got it, you know, you could pause and go back to it and pause, so you'll see the number and put it down. Divided by 96634.1. Right? And let's do this one. Yeah, do I get it right? Yeah. Clear. 96634.1 minus 94579.7 divided by This is what I got. I got to be 0, 2, 1, 2, 6. 596, yeah? This is what I got, right? Let's take the little bit harder one. You remember when last time we looked at NMQX? Let's do 5, 1, QX. So the one is usually we don't write it, right? And again, visualize it. So not X, I meant let's do it 30. Let's do 30. So remember what year we are looking at 30. And now how many years we deferred the mortality? The mortality is deferred 5 years. So will be, if somebody is age 5, deferred 5 years will be 35. And what is the period T that death occurs within it? It's within 1 year from 35, so 36, right? So this is where death we are interested. And this one, there are many ways you can calculate. Let's look at the easiest way I usually look at it, because we're looking at year 30, so the denominator should be L30, the cohort that at age 30, because this is what it says, this one. Like, let's say what we mean by this one. What we mean, maybe the question will not be written this way. Maybe the question will ask you, find the probability that a life, find the probability that a life currently aged, so the current age of the life exactly 30, right? Because this is where we are. Find the probability that a life currently aged exactly 30, that this life will die between 35 and 36. So it doesn't have to be written this way. It might be written this way, but we understand that this will mean Q30, right? And we already visualize it. So a probability that a life currently, so this is where we are currently at, and then the death occurs between 35 and 36. So now, because it's currently we evaluating at age 30, so what goes to the denominator is this age, L30. But because we are interested in the death between 50 and 35 and 36, so you take the cohort that start at age 35, you subtract from it the cohort at age 36, right? And this one you can calculate it right away. You go back to your life table. So we need 30, 35, and 36. Let's quickly 30, 35, 36. Identify them so you can see where I'm getting them. We need 30. This is the first one. You need 35. This is the second one. Oh, and you need 36. Those what you need. I can't memorize them, but I have the life table with me, so I will copy them down. So 30 goes to the denominator. So L35, the first one we look at. L35 is 99556.7. Subtract from it L36, 99517.8. Everyone divided by L30, which is 99727.3. Right, do you see it? It's straightforward. So if you compute this one, let's do it together. 99556.7. You subtract from it 99117.8. So you will have 38.9 death divided by 99727.3. What I got is almost 4%. No, I mean 4% of 1%. So it's this what I got, 0, 3, 3, 9. Almost, right? But as I mentioned, actuarial mathematics, there are different ways to do it. You know, one way is if you divide this by this. One way is, let's look at it. You know, 5Q30. Where alternative way. Let's take, there are 3 ways as I mentioned before, but this one you can compute it. Let me create more space. You can compute it this way is here 30, 35, 36. Death occurs here when we are here. This one can be written as somebody age here to survive to age 35. So somebody age here to survive to age 35 is 30, survive 5 years, and then die the year after. So then Q35, right? That's another way to look at it. What's 5P30? This one you can write it quickly. Is 5P30. You can have L30, L35, right? What's Q35? Keep it Q35 because it's in the table for 1 year, right? This is 1 year, but we don't write 1 year. Let's look at L35, which already I looked it up. L35 is 9955.6.7 divided by L30, 99727.3. What is Q35? You can actually find it for 1 year, right? If you Q for 1 year, you can find it in the illustrative life table. You look at Q35, you see it here. Oh, not this one, not this one. I meant this one. So 3 zeros, 391. Right, do you see it? Because this is actually QX. 3 zeros, 391. Right, and let's verify, see what answer. We should get the exact same answer before, right? Let me just make sure that I got that number correctly. X35 is 3. Yeah, that's correct. So now let's do 99556.7 divided by 99727.3. Then multiply it by 0.00391. Should get exact same answer. Let me see what I got here. You see? Same answer. Right? So I think, you know, like with this we can, finish this quick session. So now we looked at the life tables. We looked at previously like general one, and now we looked at the illustrative life table. So this illustrative life table, if I bring a question like this in the exam, it will be the exact same life table that you have, the same, very same one. It will be attached to your exam, or maybe I'll take like little portion of it. I put it in the exam with maybe different numbers if it's portion, but if I want to include it in the exam, to be this one. So it's very good if you guys are related to this, if you can always have it ready when you watch this these sessions, that you can always refer to it. All right, see you next session.